We're up to problem 16 now. This is a problem of just what we call function notation. Function notation is this right here. It's actually pronounced f of x. Sometimes initially students might get confused and think this is like f times x in math sometimes. That's how we represent multiplication, but in this case this is function notation. F of x equals x squared minus 6. Usually by function, typically we're going to mean an equation. So in this case, function is another name for an equation. Usually function notation means that whatever variable is inside the parentheses, that's the variable that's going to be in the equation. So they give us this function, f of x equals x squared minus 6. And then they have this new expression that they want us to evaluate this expression. And that means based upon the function we were given, figure out this expression. And this is what's called function notation. Now, in case you don't understand, f of x plus h means you go get the f function. Let me write it like this just to make it very clear in case you're confused about function notation. Let's look at this first part. Let's figure out what f of x plus h is going to equal. What this means is go get the f function, and every place you have an x, you replace it with x plus h. Just as an example, a simpler example, if I wanted f of 2, that means I go get my f function, every place I have an x in my equation, I replace it with a 2. So since it's x squared, it would be 2 squared minus 6. Instead of writing x, I replace it with the 2. And therefore you would say f of 2 equals 4 minus 6 equals minus 2. We could do something like saying, what's f of a? F of a would mean take your f function, every place you have an x, you replace it with a. So it'd simply be a squared minus 6. So f of x plus h says go get your f function, and every place you have an x in your equation, you replace it with x plus h. So in this case, x squared minus 6, instead of x, I'm going to put in x plus h, and of course it gets squared, so this whole thing gets squared, and then you have the minus 6. As a matter of fact, just to make this simpler, let's go ahead and simplify this. X plus h squared, just to make it very clear, means x plus h times x plus h. Now most of you, I think, probably learned to FOIL or to multiply out these parentheses. I'm going to try and skip a step in my head. I hope I don't mess up. When you multiply these out, you get x squared plus 2xh plus h squared minus 6. So that's actually this piece right here. So now, that's the most complicated piece. So let me do the rest. And actually, let me take a minute. This is actually a very special expression. It's called the difference quotient. If some of you go on and ever take a calculus class, this is one of the first expressions you'll learn to use, because this is really one of the foundational expressions for calculus. It's called the difference quotient. So they sort of go ahead and give you a sneak preview of some of the kinds of things you'll do if you start in a calculus class. But anyway, so f of x plus h, we've already figured that out. It's x squared plus 2xh plus h squared minus 6 minus, now I'm going to put this in brackets because I'm subtracting f of x. So now I just write f of x. F of x is just what I started with. The reason I put it in brackets is because I have to be careful this minus sign gets applied to all the terms inside. And all this is over h. Now the way these kinds of problems work, at this point, if you've done it correctly, a lot of stuff is going to cancel out. So let me first get rid of these brackets. So I have to do a little more writing. X squared plus 2xh plus h squared minus 6. So minus x squared. Subtracting a negative 6. Two negatives make a positive. It's plus 6. All over h. Now let's see if I can combine any like terms in the numerator. I notice x squared here, and I have an x squared here. It's actually a minus x squared, or you can think of this as a negative x squared. So those actually cancel out. I've got 2xh. Nothing I can do with that. 2xh. I've got h squared. Nothing I can do with that. Then I've got a minus 6 plus 6. Those actually cancel out. So all I'm left with is 2xh plus h squared. And that's all over h. And then you notice I have two terms in the numerator, both with an h, and I have an h in the bottom. So I can cancel an h out of all of these. And by the time you're done, the difference quotient equals 2x plus h. All right. Hopefully not too difficult. All right, number 17, sort of a story problem, but not really. I think you will not find it too hard, hopefully. It's sort of like a business, money kind of problem. I guess maybe I can show it to you. Of course, you should have it in front of you, but let me just read it. Suppose that the revenue R in dollars from selling X cell phones in hundreds is R of X. Once again, here's function notation. So in this case, it's like our equation is big R, and it's basically saying we're going to use the variable X. So R of X equals negative 1.2 x squared plus 206x. The cost C in dollars from selling X cell phones in hundreds is C of X. Here's another function, except this time the equation is C, which stands for the cost. C of X equals 0.02 x cubed minus 2x squared plus 75x plus 600. And then they ask us three questions. So let's just talk about the setup for this problem to make sure you understand what's going on. The first thing I want you to realize is they say, suppose that the revenue R in dollars from selling X cell phones in hundreds. What does that mean, X cell phones? And then they use the phrase in hundreds. Let me just go ahead and write the equations for the revenue. The revenue is how much money, when they sell the phones, how much money they bring in from selling the phones. So here's an equation that'll tell us how much money is brought in when they sell the phones. Now it's not how much money they make total. This is how much money they bring in, but in a minute we have to subtract out the cost, how much it costs them to make the phones, and then the actual money they make overall is called profit. So this is an equation for the revenue, the amount of money that people pay them when they buy the phones. But I'm writing this here. Let's understand what X means. X is a variable, and it's the number of cell phones. Now this is a little tricky. Some people might look at this and think X is cell phones. So just for fun, if we sell one cell phone, we would say X equals 1, and we could plug a 1 in for X and do the math, and that would tell us how much revenue we have based upon one cell phone. But that's not quite right, because you notice this word in hundreds. When X is 1, what that really means is 100 phones. If we put in X2, that means 200 phones. It's almost like a shortcut. Instead of having to write 100 or 200, or if X is like 10, that really means 1,000 phones. Instead of writing 1,000 phones, they do like a shortcut, and they say, well, let's just call it 10, and we know that when X is 10, that really means we have 1,000 phones. So that's the first thing you have to realize in this problem to do it correctly. So the first part, let's go ahead and write the equation for the cost. So once again, the cost is how much it costs them to make the phones, how much money they have to spend in producing the phones. And it's 0.02 x cubed minus 2x squared plus 75x plus 600. So the idea here is that we have these two equations, and they're both functions of x, which makes sense, right? Because the revenue is the amount of money that people pay to buy the phones, and of course, it's going to depend upon how many phones you sell. The more phones you sell, the bigger the number for X is, the higher the revenue is, the more money you take in from the customers. But of course, the cost, how much it costs to make the phones, is also a function of X. And it makes sense that the more phones that you make, the higher the cost is going to be. And it turns out, the first part, they ask us to figure out the profit. The profit's P. The profit's like how much money you take home. How much money, after you sold the phones and after you pay the money to make the phones, how much money do you actually make? So it's revenue minus cost. How much money the customers pay, and then you subtract how much it costs to make the phones, and that's revenue. And what they want to do in part A is just come up with an equation for the profit. So we simply take our revenue equation, negative 1.2 x squared plus 206x, and we subtract the cost equation. Once again, I'm going to put this whole thing in parentheses. Although actually, let me start it again, because I'm really going to run out of room, because this is a big, long equation, just so it's very clear what we're doing. So here's the revenue, negative 1.2 x squared plus 206x minus my cost, 0.02 x cubed minus 2x squared plus 75x plus 600. So this is my revenue, this is my cost. Now, this just becomes a problem of combining like terms, because these terms are all either being added or subtracted. So remember, like terms is when the variables are exactly the same, including the exponents. So I notice here I have an x squared and an x, and here it's x cubed, x squared, x, and a number. So I do have some like terms, the x squareds and the x's. Let's start with the largest exponent, x cubed. This is all by itself, but remember I got this minus here. So it'll be minus 0.02 x cubed. So mark that. Now let's do the x squared. So here I have negative 1.2 x squared, and here I have a minus, or subtract, a negative 2x squared. When you subtract a negative, that means positive, so it's really negative 1.2 x squared plus 2x squared, which ends up being 0.8 x squared. So I've now taken care of those. Next would be x. Notice I've got 206x here and 75x here. However, I'm subtracting the 75x. So 206x minus 75x, I think is going to be, I'm going to check my math in a minute. I think 75, I believe, is correct. Actually, I brought my calculator. I want to be sure. So 206 minus 75, yep, 131. So that takes care of these. And the last thing left is just the 600, but remember, it's minus 600. So now, this is part A. We have an equation for the profit as a function of x. So if I were to plug in how many phones I sold into this equation, it would tell me how much money we made. And a matter of fact, that's what part B says. Part B says, find the profit if x equals 1,900 cell phones sold. So they're saying, what's the profit, which is the same thing as P, when x equals 19. Although really that means 1,900, means 1,900. But in our equation, we're going to plug in x equals 19. So we could write it in a sense P of 19, right? So I'm setting x equal to 19. The profit when I sell 1,900 phones. So every place I have an x, I'm going to put in 19. So this is times 19 cubed plus 0.8 times 19 squared plus 131 times 19 minus 600. Wow. Now this is a case where you definitely are going to want to grab your calculator, and everybody's calculator is different, so I'm just going to go ahead and use my calculator and hopefully come up with the correct number. Actually, I have the answer here, so let me just write it down. Turns out when you do the math, 2040.62, and that's money. So basically, when they sell 1,900 phones, they make a little over $2,000. And then part C, they do this thing where they say, interpret P of 19. What does P of 19 mean in sort of words? And actually, it's a multiple choice question. Here are your three choices. You can look at the question. When A is when 1,900 cell phones are sold, the profit is given by P19. When 1,900 cell phones are sold, the revenue is given, and the cost is, wow, it's a pretty simple question, right? It's obviously going to be A. All right, so that problem is not too difficult. All right, let's look at maybe one more on this video. And this one has multiple parts, and now we're going to start using a graph. So this might be a little tricky for me to do. This is problem 18. What I'll probably do is try and, let me put this on the screen. I can make it a little larger. I don't want to go off the screen. Hopefully this is the same problem you have. I know it's the same problem. I don't know if the numbers are a little different. I wonder if I can focus it some. All right. So what I might do is actually for this problem, just try and work up the answers on my paper here. And I'll try and make sure I stay on the screen. So this is a graph here. They call this graph a function, but what's interesting is if you look at the graph, it just looks like the old-fashioned. You see the y-axis, which is up and down, and the x-axis, which is left and right. But you notice the first part of the problem where they say in the instructions, use the graph of the function f shown to the right to answer parts. So this is actually the graph of a function. And really, what you could think to yourself is the y, whenever you have a y, either in a graph or an equation, it's really the same thing as f of x. Y and f of x are interchangeable. Y is the value of the function. When I look at this graph, see I look at this point right here? Let's see what this point means. This point is minus 6, 3. X is minus 6 and 3 is y. In terms of a function, the idea of a function, we would say, you know, when x is minus 6, the function equals 3. The value of y, in a sense, is the value of the function. That's why I say up here, y means the same thing as the function. If I were to go to this point over here, I would say when x is 12, the function equals 2. I could say when x is 12, y is 2, but in this case, we need to think about this as a function. When x is 12, the function is 2. Now, based upon that understanding, they're going to ask us all kinds of questions. So part A, f of negative 14. This notation here is our function notation. This is saying go find the value of the function when x equals negative 14. So we're going to go to our graph and we're going to find out where on this graph, this line, see where x is negative 14. And you can see this point down here. Look at what the value of x is. This point here is x is negative 14, y is negative 2. So this is the point where x is negative 14. We would say the function is negative 2 because the function is like the value of y. So I'd go over here and I would say it's negative 2. F of negative 4. Find the function. Find the value of the function when x is negative 4. So I'm going to go on my graph and find out where the value of x equals negative 4. Turns out it's right here. I believe it's this point here. And I want to figure out what the function is. Well, the function is whatever y is. So when x is negative 4, the function is 2. They actually do a couple more for part B. Find f of 12. So I go find on my graph where x is 12 and then find the value of y, which is my function. Looks like that's this point right here. This is where x is 12. Since y is 2, that's the value of my function. I put a 2 in. F of 0 means go to the graph where x is 0 and find the value of y, which is my function. Looks like at this point right here, when x is 0, y, or the function, is -1. All right, so it's really not very hard. These graphs of functions, as long as you understand what they're asking for. All right, they keep on going. C says, is f of 4 positive or negative? So they're not even asking you for the number. They're just saying, is it a positive or negative number? So let's go on the graph and find where x is 4, which is down here. Looks like the function is -2, so we say it's negative. Now they do the same thing for f of -6. Is it positive or negative? I go find on my graph where x is -6. It looks like it's this point up here. The function is 3, so the function is positive. Part E, for what value or values of x is f of x 0? Okay, here, it's a little different now. So now they're saying, go find the values of x. Before all these previous problems, they've given us the value of x, and then we go find the function at that value of x. Now they're saying, hey, let me give you the value of the function. In a sense, they're saying go to the graph and find the points where y equals 0 and tell me what the value of x is when the function is 0. So I go to my graph and I go find the point, and there could be more than one point where the function is 0, or really where the value of y is 0. Well, I know y is going to be 0. Actually, here's the first one, right? This point right here, -12, 0. Y is 0, which means my function is 0. What's the value of x when the function is 0? It's -12. So I would put a -12 here. But I have to check, there might be more points where the function is 0. Matter of fact, if I keep checking, I go to this point here. At this point here, the function is 0 because y is 0. And it looks like that point is -2, 0. So when x is -2, the function is 0. And there's actually a third point where the function is 0 right here. See, you see here, my y is 0, which means the function is 0. That happens when x is 8. So there are actually 3 values of x where the function is 0. All right, F is another twist. For what values of x is f of x greater than 0? And here they say, type a compound inequality, use a comma to separate answers as needed. All right, a compound inequality. That could be sort of ugly. I like to do intervals, but they're asking for a compound inequality. I might have to check the answer to make sure I'm giving what they want. But let's talk about what we're looking for. So now they're saying, okay, find the values of x. What does f of x greater than 0 mean? That's another way of saying, where is the function going to be positive? And since the function is really the value of y, basically we're looking at this graph and we're trying to figure out what part of this graph is y positive. Or that means, is the function positive or is the function greater than 0? So you look at the graph. If you start out, what about this first part? What is y here? What is the function? It's actually negative, right? Because my x-axis, that's where y, or my function, is 0. Below it, it's negative. So this first part, it's negative. But then once I get here, all of a sudden my function is positive. So this is what I'm looking for, where it's positive. And then look what happens here. As I keep moving to the right, all of a sudden it goes negative again. But then when I get to here, it goes back positive. What they want me to know is, what are the values of x where the function is positive. In other words, it starts right here. What's the value of x where this thing goes positive? It looks like it's going to be negative 12. So negative 12, when x is negative 12, all the way to this point, which is where x is negative 2, it's positive. So let me just make a note. From negative 12 to negative 2. For those values of x, the function's positive. Then it goes negative again. And then when I get to this point x is 8. From x equals 8 to x equals 12, it's positive again. So it looks like also from 8 to 12. So I think what they're going to do is, I think we're going to say, maybe my guess is, compound inequality is going to mean when x is greater than negative 12, but less than negative 2, right? So we're saying when x is between negative 12 and negative 2. That's how we write it. That's the first part. But we also have a second part. So now we say, we start again at 8 when x is greater than 8, but less than 12. And I have this answer written down. I'm going to check it real quick just to make sure I don't mislead you. Yep. That's the answer they want. Although there's one little twist I missed. I have to put, so they're asking where is the function greater than 0. All of these points, negative 12, negative 2, 8, that's where the function is actually 0. So we don't include those points. That's why we have just the less than and the greater than. But 12 is different because when we get to this point here, this point is actually positive. I need to include this point here. These 3 points, I did not include them, but this point I have to include. So actually to get the correct answer, because this is saying, where is the function positive? At negative 12, negative 2, and 8, the function is 0. It's not positive. So we can't include those points. But when we get to 12, at that point, the function is actually positive. So we include the 12. That's why we put the less than or equal to. All right. G, let's look at the question, then we'll have to look at the graph. What is the domain of f? Type as a compound inequality again. All right, the domain of a graph is a very simple concept. The domain, we're talking about the values of x. When I talk about the domain of a graph, I'm looking at all the possible values of x. So what you do is you look at your graph. X's is the horizontal axis. What you do is you go all the way to the left and you say, what's the smallest value of x on this graph? Well, it's this point right here. It looks like it's minus 14. So the smallest value of x is minus 14. And then you go all the way and say, what's the largest value of x? And it looks like it's this point here, 12. So really what you say is x's go from minus 14 to 12. That's my domain. That's what domain means. What are the possible values of x? For this graph, what's the smallest value of x and what's the largest value of x? And because x is everything in between. So if we were to write that as a compound inequality, I think what they want us to do is to say we start at negative 14, and I think we say less than or equal to. So this is basically a way of writing negative 14 to 12 and everything in between. Now H says the range. Range, So if I say domain, I'm looking at x's, range, I'm looking at y's, and it's the same principle. I look at my graph and I say, what are all the possible values of y? What are all the values of y for this graph? So what you do is you go to the lowest point, the smallest value of y. And it looks like it's going to be either here or here. This one is -2, and this one is also -2. Two different points. But the smallest value of y is -2. So we go from -2, and now we see what's the largest value of y on this graph. Well, this one, at this point, y is 2. Of course, this one is 3. So it looks like the largest value of y, or the largest value of the function, is 3. And the range is looking at what are all the values of y for the graph. So it looks like on this graph, the values of y go from -2 to 3. So I would say -2 to 3. All right, domain and range of a graph, not real difficult. What are the x-intercepts? X-intercepts, those are the points where the graph crosses the x-axis, right? Like intercept or intersect. Where does the graph cross the x-axis? Now here, all they're asking for is the value of x. They don't want an ordered pair. They just want numbers. So I'm going to go up here and I'm going to look at every place where this graph crosses the x-axis. So it first crosses it here at -12, 0, but the value of x is -12. So I put a -12 here. And then I keep looking and I see there's another point where the graph crosses the x-axis. So this is another x-intercept. And this point is 0, -1. Nope, it's this one, -2, 0. So the x-intercept is -2. So there's a second x-intercept. But there's actually a third x-intercept because here it crosses the x-axis again. This point is 8, 0. So the value of x, where the graph crosses the x-axis, is 8. So there's actually, and I'm going to make sure that's the form they wanted in. Yep, they just want the intercepts. What are the y-intercepts? That means where does the graph cross the y-axis, and when it crosses it, what are the values of y? So let's see, where does this graph cross the y-axis? It actually only crosses it once. So this right here is my one and only y-intercept. And the value of y, it looks like it's 0, -1. So it looks like the value of y is -1. So I only have one y-intercept. Okay. How often does the line y = 1 intersect the graph? So this is saying, okay, if I were to graph the line y = 1, if I were to draw a normal graph, and I told you please graph y = 1, y = 1 is just a horizontal line that goes through 1 on my y-axis. So if I go up here and I sort of draw or imagine myself drawing a line, here's 1. And if I sort of draw a horizontal line, it's going to cross it once, twice, and if I go this direction, it looks like it would cross the graph 3 times if I were to draw a horizontal line that goes through y = 1. So it looks like I would say 3 times. And I actually think there are more questions on the next page. There are a few more. This is like L. Wow, this is amazing. How often does the line x = 4 intersect the graph? So now x = 4 is a vertical line up and down that goes through x = 4. So here is x = 4. If I were to draw a vertical line, it looks like it would just cross the graph once. So I guess the answer to this one, just crosses it one time. M, for what value of x does f of x equal -2? So now they're saying, okay, go on the graph, go find out where the function's -2 and see what the value of x is at that point. So I'm going to go to my graph and figure out where the value of y or the function is -2. So -2 is right here. It looks like this point, the function is -2. So the x is -14, but there's a second point right here where once again the graph for the function is -2. So there are actually 2 points where the function is -2. For the first one, the x is -14. For the second one, the x is 4. So my answer would be -14 and 4. There are 2 values of x where that function equals -2. Here's another one. For what values of x does the function equal 3? We go back to the graph and we say, well, let's go find on this graph where the function or the value of y is 3. 3 is like right here. Looks like I got this point here, and there's no other points where this graph equals 3. There's only one point, and what's the value of x? -6. So, wow. That was like 13 or 14 parts. But hopefully, really not too difficult once you understand this graph as a function and function notation for a graph, not too hard. All right, that'll be it for this video.